So speed of reaction. So speed is speed is distance over time. Okay. But what about a speed of reaction? So it will be like this.
Rate of reaction.
Rate of reaction. Speed of a reaction is similar to a rate of reaction.
Amount of time needed to finish the reaction.
Yes, correct. Okay, so what we measure is like this. Okay, let's say I take a test tube and I put hydrochloric acid. Okay, and I put a piece of zinc. Let's say I put 1 gram of zinc. Okay, now the chemical equation is like this. Are you okay?
Yeah.
Yeah. All right. Now, can you write this down and tell me what are the states?
There is gas,
Which one is gas?
H2.
Okay. What about zinc?
NCl2 is solid. I mean liquid.
No, it's aqueous because it dissolves inside. Okay. This one is a solid and this is an aqueous. So what you see initially is, first it's an aqueous, then you see a piece of solid. When you put it inside, you will have bubbling. The bubbling is the hydrogen gas and the zinc will eventually dissolve. Okay? Can? All right.
Yeah.
Now let's say for rate of reaction, one extra thing that we do is we put a timer or stopwatch. Okay? All right, we put a timer. So let's say the 1 gram of zinc in 10 seconds, the 1 gram of zinc is completely dissolved. Okay? So the rate of reaction is the mass of zinc over 10 seconds. So it's 0.1 gram per second. Correct or not? Do you
Yeah.
understand this unit? Is it
Yeah.
similar to speed?
A bit.
Okay. All right. So now, if I don't want to measure the mass of zinc, let's say I measure the volume of hydrogen gas. In the same 10 seconds, there is 10 centimeter cube of hydrogen gas. So my rate of reaction
1
is,
centimeter cube per second.
yes, correct. Okay, can. So this is how we measure rate of reaction. Either the amount of reactant used over time or the amount of product formed over time. Okay, can. Got it?
Yeah.
All right. Now, certain times reactions are fast, certain times reactions are slow. So we're going to talk about how to measure a rate of reaction and when is a reaction fast and when is a reaction slow. Alamak, wait, ran away. Okay, can see? Yeah, okay. Now there are few experiments
Yeah,
that we
can.
can do. Okay. Now, what's the problem with just counting bubbles or just counting the bubbles like that?
What?
What's the problem with counting bubbles? If I want to count bubbles,
The size of bubble might be different, huh?
yes, the
Or we
size of
might
bubbles might be different.
like miscount it. What?
Yes, correct. So it's not a very good thing to do. Okay. So what happens is we use different apparatus. So I'm just going to talk about this reaction, just the zinc and hydrochloric acid. Okay. So let's say I do this. Okay, can you tell me what's this apparatus?
Conical flask.
Yes, correct. So zinc. Okay, now there's a few things we can do. The easiest thing we can do is just put this thing here. Okay, can you tell me what's the name of this apparatus?
Gas. Gas syringe.
Very good. Gas syringe. So a gas syringe will give us more accurate results. Okay, more accurate reading. Can I
To
understand?
like see the gas produced one.
Yes, the volume of gas produced. So
Because you
it's
can
more
see like
accurate reading.
the amount they go, like it extends.
Yes, correct. Okay, can you understand?
But enough, meh? Like the volume of gas can push the syringe back.
Yeah, can. This is specifically a gas syringe.
Also, it's like really light. It's not like
Yeah.
the normal
It's not like the
medicine
normal
syringe.
syringe, not like the injection syringe. It's different.
Or it's not like the medicine type.
No. The shape is the same, but it's much, much larger and it's very smooth. Okay, it's very, very smooth. So it's very easy to slide out. Okay, can?
Okay.
All right. So that's one way of doing it. So of course we measure the time taken lah. Okay. Now, if I were to do an experiment, right? And I measure the volume of it. So you're going to see a lot of graphs in this topic. So you measure the volume of gas against time. Okay. So what do you think is the volume of gas at T equals to 0?
The volume of gas is also 0
Yes, correct.
or
Okay.
G.
Yeah. So as the reaction, you will see a graph and it will look like this. Okay, every single graph you see will exactly look like this. Okay, so this means that, can you see this graph shape? Which one is faster?
What do you mean which one is faster?
Which time the reaction is faster? The front or the back?
The front.
The front. So at the start, it's very, very fast. Okay, because the curve is very, very steep. And then after that, it eventually becomes flat. When it's flat, it means it stops. Now, every single reaction will be exactly the same. Okay? Where at the start of the reaction is really, really fast. And then after that, it will become flat. Okay? Can? All right. So we're going to talk about, I'm going to teach you about this and I'm going to show you a few different other experiments. Okay. Now, this reaction is metal, acid and metal. You get salt and hydrogen gas. And the reason we can measure the rate of reaction is because there is hydrogen gas. Okay? Ken, I'm going to show you another experiment, another kind of reaction. Okay, I'm sure you learned this before in year 7, 8, 9. Can you tell me if I take acid plus carbonate, what do I get? Eh? So what you know or not?
I think
Acid and metal, acid and base, acid and carbonate.
salt
Salt, yeah.
and then water
One more thing.
and carbon dioxide.
Yes, correct. Okay, you get salt, water. Now, do you think this is something that we can measure rate of reaction?
No.
Think carefully, think carefully.
It can.
Why? Because what is released?
Carbon dioxide.
Yes, correct. Okay, so for example, if I take nitric or hydrochloric acid, I use the same acid. Hydrochloric acid plus calcium carbonate. Can you please try and balance this equation for me?
Wait, two HCl.
No. Sorry?
Two
2
HCl.
HCl. Yeah, correct. Okay. Now, this experiment, I can do just now that one. I can do just now that one, or I can do a different one. Have you seen this before? So, acid, calcium carbonate. Here's water. This is a measuring cylinder that is inverted.
Inverted measuring cylinder.
Yeah. Okay. Tell me, how will this get the carbon? How will this measure? What will happen? The gas will flow through the delivery tube, and then what will happen? It will push the
Water.
water down, and so you can measure the volume of gas collected like this. Can you understand?
Yeah.
Okay. So this is another kind of reaction. Okay. All right. So another thing we can do is, okay, here's cotton. Same experiment. Okay, do you know what's the electronic balance?
Yeah. The one measure the mass one
Okay.
by electronic.
Okay, you look at this, you look at this apparatus. Okay, you draw this apparatus, you tell me, how do I measure the rate of reaction?
You remove the cotton.
No, no, no. Will the cotton, you don't remove the cotton. Do you think the cotton will let the gas pass through? Yeah, ma,
Yeah.
that's why it's called cotton, ma. So
Yeah.
carbon dioxide will pass through the cotton.
So you can
Okay.
just see the difference between the
Yeah.
mass.
So what will happen? What will I measure? This one
Decrease
I measure volume of gas. This one I measure the
mass.
mass loss. Okay. Can you understand?
Okay. Wait. Oh. Okay.
Okay. Can.
Yeah.
Okay. Now Do you think, okay, look back at this equation. Remember this one I showed you just now? Okay, do you think I can do this one, the mass loss one, for this chemical reaction? That means here I put zinc and hydrochloric acid.
You put zinc and hydrochloric acid.
Yeah. What do you think is a good way to do the experiment?
No,
Why not? Why do you think is a problem?
there wouldn't be much gas produced.
No, the amount of gas produced is still the same. Okay, gas will still be produced. Something else, something else. Think a bit.
It'll be very too reactive.
Something to do with the gas.
Toxic.
No, I want you to look at the molar mass of hydrogen and molar mass of carbon dioxide. Think. Calculate the molar mass of both. Think. How much is the molar mass of hydrogen?
Hydrogen gas has 2 grams per mole.
Okay, and then carbon
Carbon
dioxide
dioxide
is
has 44 grams per mole.
okay. So I don't use hydrogen gas for this experiment because it will be too little mass change. I can't really measure. Understand? Make sense? Okay. All right. Now, okay, the last experiment I'm going to talk about is hydrogen peroxide. Okay, hydrogen peroxide has the formula of H2O2. It decomposes to form water and oxygen. Can you try and write for me a balanced chemical equation for this?
H2O2 becomes H2O and O2.
Balance it.
Okay, 2H2O2 is 2H2O plus O2.
Correct. Okay, can. Now, this one produces oxygen. I can do either one. I can do this or I can do this. Doesn't matter.
Okay,
Okay, can you understand?
yeah.
All right. So these are experiments that I need to set up. But if I just do this, very easy. I just look only. I just look and see whether it dissolves or not. Okay. So a simple experiment, you can do this. A more experiment where you want to measure and do the graph, then you do this kind of experiment. Make sense?
Okay.
Okay. Now, okay, can you draw this?
Okay.
All right. So now, which one do you think, if I start the timer, or even if I don't look at the timer, I just compare, which one do you think will be faster?
40 degree.
Okay, so maybe this one takes 5 minutes and this one takes 2 minutes, for example. Okay, so what is the factor that affects the rate of reaction here?
Temperature.
Correct. So there are 5 factors that affect the rate of reaction. Okay, so the 5 factors
Five.
are temperature. Sorry, what do you say?
Like 5.
There are 5, yeah. Temperature, pressure, concentration, particle size, and catalyst.
Okay.
Can? You okay? Can you understand so far? All right. So let's look at this simple one. Okay. So this one is obviously about temperature lah. Okay. Now, before we get into detail, okay, let's just do something simple. If the temperature is higher, do you think the rate is higher? So basically faster or slower? If the temperature is higher, faster or slower? ZiHua, you're muted.
Faster.
Faster. If the pressure is higher, faster or slower?
Pressure.
Mm.
Faster.
If the concentration is higher, faster or slower?
Faster.
Correct. And then particle size. Do you know what particle size means?
Yeah.
That means if it's powder or is it a piece. Okay. So which one will have a higher rate? The particle size smaller or the particle size bigger?
Particle size bigger.
I want you to think. Sugar, powdered sugar and rock sugar, which one dissolve faster?
Powdered sugar.
Yeah. So particle size smaller or bigger?
Particle size will be
The smaller the
smaller.
particle size, powder will dissolve faster lah.
Yeah.
Can you understand?
Mm-hmm.
Okay. Catalyst, you know what's a catalyst? Catalyst is a substance that increases the rate of reaction, but it doesn't get changed itself. Okay, so and anytime you add a catalyst, it increases the rate. Okay, can?
Okay. Yeah.
All right. So now we're going to talk about one experiment at a time, one reaction at a time. Okay, let's look at this. Okay. Do you remember what I taught you last week about uh activation energy?
Yeah.
Hmm?
Activation energy.
Remember the activation energy? Okay,
Uh-huh.
so hydrogen molecule and iodine molecule, in order for them to react, they have to first break bonds or form bonds. Remember, it's in minus out, right?
Yeah.
Okay. So which one?
Form.
In You look at your notes last week? Go look at your notes last week.
Red.
Come on, do you remember?
Red.
Break bond. So absorb or release energy. I thought you were saying wait, so
Break
I'm
bond.
waiting.
Oh,
I didn't hear you say break. I thought you were saying wait, so I'm waiting.
like
All right. So first you break the bonds, so you absorb energy. Okay. So the energy that is absorbed to break bonds is known as what? What kind of
activate.
energy? Activation energy. Okay, so what happens is, let's say the activation energy is 100 lah, 100 kilojoules. Okay, very simple. So let's do a simple diagram like this. Okay, so now, in order for them to react, for them to react, okay, they have to collide. The two particles cannot just look at each other, ma. They have to collide, okay, and break the bonds. All right. They have to collide with how much energy? How much energy do they have to collide with? How many kilojoules?
100.
100 kilojoules. They must collide with 100 kilojoules. So let's say they only collide with 99 kilojoules. Will a reaction occur?
No.
Okay. If they collide with 10 kilojoules, will a reaction occur?
What? How much?
10.
No.
Okay. If they collide with 100 kilojoules, will a reaction occur?
Yeah.
If they collide with 101, will it occur?
Yeah.
Yes. Okay. So the minimum energy required is activation energy. Okay, 100 kilojoules. Okay, so now let's use this in the context of temperature. Now, this is my zinc, and this is the hydrochloric acid particles. In order for reaction to occur, it has to collide. Okay, they have to collide. Okay. So what happens is when the temperature increases, okay, the particles move faster or slower.
Particle move faster.
Okay, what kind of energy does it have?
Kinetic.
Okay, so particles
And they're not even start working on it.
tomorrow. Hold on, tomorrow 8:30 they will come.
They said Wednesday.
No, he came and see today.
Oh, today's check. Gym itself.
No, this is the part. Particles have more kinetic energy. Kinetic energy, the symbol is EK. Okay.
Okay.
All right. Now, because now the particles have more energy, do you think more particles will achieve the activation energy? Think of energy as money. If I give them more money, do you think more of them can achieve 100 ringgit?
Yeah.
Yeah. So more particles can achieve activation energy. Get it?
Yeah.
So we can say more particles collide with activation energy. The symbol is EA. Okay. Okay, ready?
Yeah.
Okay, now this part that I'm going to tell you about is a little bit, it's not very confusing. It's just a little bit confusing, okay? Okay, but it's very easy. It's just new words. Now, this whole thing that I'm teaching you is called collision theory. Okay, it's just a name. Okay, it's called collision theory. So collision theory says that when particles want to react, they must collide. And when they collide, they have to collide with sufficient energy. Okay, so the more times they collide, the chances of reacting is higher or lower.
The more time they collide,
The chances of reacting is higher or lower.
higher.
Higher. So the more often they collide, it's called collision frequency increases. Collision, okay? So
Collision frequency.
yeah, collision frequency. Frequency means how often increases. Okay? All right. Now, collision frequency means how often they collide with each other. Okay, Can? Okay, now, when they collide, sometimes got a product, sometimes no product. Okay, because sometimes they collide not enough energy, right? Now,
Yeah.
when there is a product, it's called an effective collision. Effective collision means got product. So effective collision frequency also increases. So that's why the rate of reaction increases. So this is a 4-mark question that they will always ask you.
So not all the collision is effective. Some will be like
Yes,
just
some not
they won't
effective, but
react.
the more times they collide, the more chances of having an effective collision, right?
Oh, okay.
Ah,
Okay.
Can?
Yeah.
Okay. Yes. Can Sana?
Yeah.
So now, that is temperature. So pressure and concentration is almost the same. Okay. The difference is pressure is only applicable to gas. Okay. The reactants and gas and the reactants are gas. And concentration is only applicable to aqueous solution.
Okay.
Okay. Now, You draw this, and I'm going to illustrate something. Okay, now 1 and 2, you done? ZiHua? Okay, 1 and 2 illustrate gas pressure. Okay, which one do you think is high pressure, 1 or 2?
2, because
2.
the like area is smaller.
Okay, A and B illustrate concentration of acid. A or B, which one is a higher concentration?
A or B, ah. B has a higher.
Okay, now don't you think this and this, basically the particles are just closer together?
Yeah.
Yeah, so the explanation for pressure and the explanation for concentration is actually the same. When the concentration is high or when the pressure is high, they are basically just more particles in a volume. Okay, because gas is also volume, liquid is also volume 1. So we say there are more particles per unit volume. Understand?
Okay.
Okay, so they collide more often or less often?
More.
Okay, no need to write. Later I'll write the whole chart for you. Okay?
Oh, okay.
All right. Now, the next one is uh surface particle size. Okay, like I told you just now, when there is powder and there is pieces, okay, which one is faster?
What?
Powder or pieces? Okay, think of sugar. Okay, powdered sugar and rock sugar. Which one is all faster?
Powder.
Powdered sugar. Okay, so do you like do you like cake?
Okay.
Okay, do you like icing on the cake? Are you an icing person?
I like cream.
Cream. Okay, now let's say this is a cake. Okay, where will I put the cream? On the top and on the sides,
Yeah.
right? Okay, now let's say I cut this cake first before I put the icing. I cut it first. Okay, now after I cut it, is it still the same cake? Same size, right? Still the
Yeah.
same thing, right? The
It's
total,
just a
if
different
this is a
portion.
1 kg cake, this is still a 1 kg cake. But the difference is, once I cut it, do I have more surface or less surface?
Do you have more surface or less surface?
Yeah, if I cut it,
More.
will I be able to put more cream or less cream?
More.
More cream. Because not only I put the cream on the top and on the sides, I also put it in the middle side. Correct or not?
Yeah.
Or is that like cream overload? Imagine if they cut the cake only, they put the icing. Wow, everybody will be going mad. Correct or not? Okay, there's so much cream. Okay, so when the particle size is smaller, the total surface area is larger. Okay, the total surface area is larger. So meaning they will have more collisions or less collisions.
Less.
Total surface area bigger. Think again.
Total surface area larger than collision removal.
More collisions, right?
Yeah.
Okay. So that's why when you use powder, it's faster. That's the reason. Okay, can understand?
Yeah.
Okay. So concentration, pressure, particle size done, temperature done. Now we're doing the last one, catalyst. Okay, catalyst is very special. Okay, now like this, Remember just now our reaction. What is the activation energy? Do you remember this one, the simple one? 100, right?
Yeah.
Okay. Now, here's the thing. When you use a catalyst, it's the best to increase the rate because a catalyst, you don't need to increase the temperature, no need to increase the pressure, no need to make the particle size smaller. No, basically, they just get a massive discount. Instead of needing to collide with 100 kilojoules, you only need to collide with 10 kilojoules. Imagine instead of the chocolate being sold for 100 ringgit, the chocolate is now sold for 10 ringgit. Do you think there will
Wow.
be a lot of people buying it?
Wow.
Yes, right. Okay.
Yeah.
So only catalyst lowers the activation energy. Do you understand? Now, are the particles colliding more often?
Yeah.
No, they're not colliding. The collision frequency doesn't increase. Okay.
No, means but like
No,
the
they're still colliding
rate
the
of
same, but
effective collision increases.
yes, correct. Effective collision frequency increases. Can you understand?
Yeah.
Okay, so we're gonna make this all into one table. Okay, let me try and make it prettier. Okay. So temperature, pressure, concentration, particle size, catalyst. Okay, temperature higher, pressure higher, concentration higher, particle size smaller, catalyst just has to be present. No need to be big or small, just present. Okay. The kinetic energy of particles increase and more particles with activation energy. Okay.
Okay.
Both of this, the amount of particles per unit volume. That means the particles are closer together, increases. This one is larger surface area. This one is the activation energy is lowered. Okay? Can this, and this all cause collision frequency increase. But this directly already effective collision frequency increases. Okay, do you understand? So if this increases, rate increases. Okay, can you please draw this? Are you done?
Almost.
Huh?
Almost.
Almost. Okay. I go by. You just send me the photo. I'm gonna go for a walk. Okay, just send me the photo.
Done.
Okay. Can I understand?
Yeah.
Okay. All right. I'm gonna try. We're gonna try some questions now. Okay. All right. Just simple reactions. Mm, Okay. Okay. This is two graphs to show the reaction between calcium, calcium carbonate and sulfuric acid. Okay. All right. Look at the question.
A.
Okay. Again. Okay, I want you to think of this way. If I cook chicken, you cook chicken. I cook 1 kg chicken, you cook 1 kg chicken. I cook at 50 degrees Celsius, you cook at 100 degrees Celsius. Who will cook faster?
Me.
But then, in the end of our reaction, do we both have 1 kg? Or did your one suddenly grow to 2 kg? Is it still 1 kg?
Yeah. It just increase
So, does temperature
makes the
change the
time
amount?
faster.
Sorry?
It just makes the time faster.
Yes. So,
More calcium carbonate was used.
so Wait, this is high temperature, this is low temperature. You will get the same total. More calcium carbonate was used in experiment 2, but it doesn't make it faster. If more calcium carbonate was used, it would be like this. Okay? Think again, think again.
More calcium carbonate was used.
No,
in-
no, no. Okay, so it's not D because it will become one, the same. Like this. This one, look at this one. Experiment 2 is faster or slower?
Faster.
So it's faster and more. Okay, so think again. What can make something faster but also the amount of moles more?
More concentrated.
Yes, correct. Understand?
Uh-huh.
Understand why or not? Because concentrated also more particles in the product. Make sense?
Yeah.
Okay. All right, we're gonna try one more. Okay, look at this. Okay, what's your answer?
Sulfuric acid is higher temperature is used in S.
Which one? A or B? Or C or D? You read carefully first.
More concentrated in T.
Okay, student, solid between solutions are reacted experiment performed as it is which the mass reaction class is recorded. What's the answer? A, B, C, D?
B.
Correct. Okay, good. Okay, we try one more. This one is structure, okay? Can see?
Yeah.
Okay. You tell me your answer. I write for you. Okay, what's my question?
As time increases, volume of nitrogen increases.
Okay, so
Rate of reaction
this question,
decreases.
yeah.
As
Okay, so
time increases, rate of reaction decreases.
no, so this kind of thing, okay, the rate, so it's always a rate, the rate decreases with time and then becomes, when it's
Because
flat, it becomes zero.
it
Okay,
stops.
yeah, the rate decreases with time, then becomes zero. Or you can just, if it's 1 mark, you can just say rate decreases with time. Okay. Why in one reaction a rate will decrease? Which factor do you talk about?
The kinetic energy will slowly decrease
No. In one reaction, why does it stop and then become zero? In one reaction.
because
Which factor?
the
Which factor
reactants will
can,
be used up.
okay, reactants used up is not a factor. Which one? Temperature, pressure, catalyst, concentration, or
Or
particle?
temperature will decrease over time.
No, why would the temperature increase or decrease over time? No logic, no. Think, some more.
Gets
Close,
colder.
close, close. Huh?
It gets colder.
Why would it suddenly randomly get colder? Why would it randomly get colder? No. Think some more, think some more.
Oh my god. Random
Which one? Temperature, pressure, concentration, catalyst?
pressure.
Concentration. Because there's less and less particles. Get it? So always, this is always concentration.
I was thinking like pressure because less particle in a certain area. That is concentration.
No.
Yeah,
Okay,
that is
it's always the
concentration.
concentration, and you must mention of who? Of organic solution. Decreases with time. Okay? Decreases with time. And then you start. Okay? If it is catalyzed by copper powder, what do you think will happen? Will it be faster or slower? Hmm?
It will be faster.
Faster. And then the total will be the same or
Same.
higher? Same.
So is it something wait, like this?
Like that. And then,
Eh,
correct. Yeah, just lower a bit.
Wait, like this. Ah,
Okay. All right. Do you understand?
yeah.
Okay. Please study. I will see you next week. All right.
Bye-bye.
Bye-bye.